Hey class, welcome to our Algebra 1 Plus Chapter 3 review. We are getting ready for our upcoming quiz on Chapter 3, so we want to make sure we are confident with all of the skills that will be included on that quiz. So as a reminder, the things that we need to know, these are the skills that you should be confident with going into Tuesday's quiz. So when you're studying, ask yourself, am I comfortable with identifying linear equations? What are the red flags we've talked about for identifying linear equations? Can I write an equation in standard form? What is standard form? Can we find X and Y intercepts? So ask yourself, if I asked you to find an X and Y intercept, do you know how to do it? If not, let's look back at our notes or watch the video. The beauty is that's what we're going to go over. The next thing we want to make sure we can do is find the 0/root/solution of a linear function. So we've learned 0, root, and solution, they're all the same thing. We're going to talk about that in a little bit, but we need to know how to find the 0, root, or solution if given a linear function. Next up, we need to know how to graph equations. Now, we've learned two strategies for doing this, using a table and using those X and Y intercepts. In addition to graphing an equation, we need to be able to find the slope of an equation. So that's going to be requiring our slope formula. In addition to finding slope when given points, we are going to also have to find the missing value in an ordered pair. Now this is when they're going to give us the slope and most of the information for both ordered pairs, but there will be one number missing, and it'll be up to us to work backwards to find that. And the last thing we want to be able to do is explain the slope of a situation, of a graph, in the context of a real-life situation. So explaining, what does the slope mean? If our slope is 5/2, well, 5 what? 2 what? What does that mean? So we're going to talk about that as well. Now, let's jump right in to our first topic, linear equations. So, our question asks us to determine whether each equation is a linear equation and write yes or no. If it is yes, then we want to write it in standard form. So let's just remind ourselves, what is the standard form of a linear equation? It is ax plus by equals c. So you're going to need to know standard form. If you don't already know when I ask about standard form that it is ax plus by equals c, then that's something you want to study before the quiz on Tuesday. Now, if we're looking for looking to write it in standard form, it needs to be a linear equation. And there are a couple red flags, things that we've talked about that tell us that an equation would not be linear if we were to graph it. So those things, those red flags we've talked about, those are exponents, multiplying variables, so that's, for example, if we have x times y, xy, and in the same sense, dividing by a variable. So that's what we talked about when we have the variable on the bottom of an equation, or I'm sorry, bottom of a fraction, the denominator. That means we're dividing by a variable, which means that it is not going to be linear. So these are the red flags to look for. So let's look at number 1, 7x minus 8y equals 4 minus 2y. Now, before I determine if this is in a linear equation, that I want to make sure to combine all like terms and simplify it as close to standard form as I can get to see if any exponent or any multiplication or division pops up when I use those inverse operations to rewrite my equation. So here I have 7x, there's my ax, minus 8y, there's by, equals 4, c, my constant. But I also have minus 2y. So I want to combine that with the y over here so that I'm in standard form. So we get 7x minus 6y equals 4. Now we can see, do we have any exponents? Nope. Do we have any variables that are being multiplied together? No. And are we dividing by any variables? No. So yes, this is a linear equation, and this is our standard form. Let's look at the next one. 12x equals 7y minus 10y. Well, I see the x and y. I don't see a constant, but I'm going to rewrite it and see how it shakes out. So first thing, I see like terms, so let's combine those. 12x equals 7 minus 10, negative 3y. Now, it doesn't look like a linear equation, but I don't have any of my red flags included. So I have an inkling that this could be linear, but to make sure, I'm going to try and put it in standard form. Now, standard form tells me I need x and y on the same side of my equals sign. So I'm going to move my 3y, and I get 12x plus 3y equals, well, I've canceled these out, so all that's left over here is 0. But we can write that 0 because that's technically a solution of our equation. So 12x plus 3y equals 0, there's our standard form. So this is a linear equation. It can be set equal to 0. That's fine. Next up, 4y squared plus 9 equals negative 4. Well, we've got ourselves an exponent here, so we can automatically cancel this out. This is not linear. And then we have x plus 1 over 7, or 1 over y equals 7. We're dividing by a variable, not linear. All right. So that's how we would identify linear equations. If any of that felt a little confusing, go back, watch the video again, or review some of our notes and homework assignments that we've done. Next up, let's talk about X and Y intercepts. So in these next examples, they're giving us an equation, and we need to find the X and Y intercepts, and then we're gonna graph them. So let's look at our first examples. 1/4 x minus 3 equals y. So I have xy, my constant. It's a linear equation, no exponents, no variables in the bottom are being multiplied. So to find my x and y intercepts, this is where we substitute 0 for each of the variables to solve for the other variable. So if I want to find my x-intercept, I want to solve for x. So I'm going to replace my y with 0. Now, from there, I add 3 to the other side. That gives me 1/4 x equals 3. And then I want to get x alone, so we multiply by the reciprocal. That gives me x equals 12. So my x-intercept is 12, 0. Now I'm going to do the same thing for my y-intercept, but this time I'm going to replace x with 0 and leave the y to solve for. Now 1/4 times 0 is 0, so -3 equals y. That means my y-intercept is 0, -3. So that would be my answer. Remember, it's an intercept point, so it needs to be written as an ordered pair. Now let's go down to our graph and graph these intercepts. So my first intercept is 12, 0, and my second one is 0, -3. Now looking at my graph, it's not big enough to fit an x value of 12. So I'm going to actually turn this into a graph that counts by 2's. So I'll have 2, 4, 6, 8, 10, and 12. Then 2, 4, 6, 8, 10. Now to graph it, we're going to place each of our intercept points on the graph. So the first one is 12, 0, so that's going to be over here. And then my second one was 0, -3. So 0, this is -2, so -3 would be right here. Once you have your intercept points placed on your axes, I want you to connect the dots with your line. Now remember, a line should extend past your points and have the arrows at the end, because this is just a section of a line that continues on forever and ever. It's kind of like we've zoomed in on just this section. So there's my first graph. Let's try another one. 5x plus 3y equals 15. Well, let's find our x and y intercepts. So my x-intercept, we're going to rewrite our equation and replace y with 0. So we get 5x equals 15. Then we finish solving for x, so we divide by 5, and we get x equals 3. So our x-intercept is 3, 0. Now let's do our y-intercept. If we're solving for y, we replace the other letter with a 0. So 5 times 0 plus 3y equals 15. 5 times 0 cancels out, so I have 3y equals 15. Divide by 3, and y equals 5. So our y-intercept is 0, 5. Now we have our x and y intercepts. Now let's graph them. So 3, 0, I go over 3, up 0. 0, 5, I go over 0 and up 5. 1, 2, 3, 4, 5. Now I make my points nice and clear, and then I connect them with as straight of a line as possible. Now if you're not good at your straight lines, use like the edge of another piece of paper or the edge of your ID badge to draw your straight line. All right, so those are our x and y intercepts. Now let's move on to our next question. An emperor penguin travels a distance of 70 miles each year back to the place of its birth. If that same penguin moves at a speed of 2.4 miles per hour, the function d equals 70 minus 2.4t represents its distance, d, from its birthplace, t hours after it started its journey. So our variable d represents how far away we are from where the penguin was born. And then t represents how many hours that penguin traveled to get there. So we're going to use that function to answer these questions. First, we're being asked to find the zero of this function. Now, we learned in our vocab that the zero of a function is the x-intercept of that function. We might also hear this referred to as the root of the function. So to find the x-intercept, we're going to replace the y value with 0. But you might be saying, I don't see a y. Which one is y? So when we have a function like this, the number or the variable that is isolated is y. And the variable being multiplied by what we're going to learn is the slope is going to be the x. So if you have a function written in this form, we would replace our variables with y and x. Then we find the x-intercept. So the x-intercept is where we replace the y with a 0. So 0 equals 70 minus 2.4x. Now we get 70 alone on the other side. So negative 70 equals negative 2.4x. Now divide by negative 2.4. If we do 70 divided by 2.4, because our negatives cancel out, we get 29.17. So the zero of this function, the value that makes our function equal 0, is 29.17. That would be our x-intercept if we were to graph it. Now, what does this value mean in context of our situation? Well, remember, d was the distance that they're traveling from their home where they were born, and t is the number of hours after it started its journey home. So d, distance, we replace that with 0. If the distance from home or from the birthplace is 0, that means they're there. They've made it. So the value for x that resulted in our distance being 0 was 29.17. So the penguin traveled for 29.17 hours to get back to its birthplace. Now, when you are answering a question like this, there are a couple things that I want you to think about. One, are you being specific? Are you explaining what the slope means in the situation you're given? So here we didn't just say the slope is 29.17 hours. We explained that that means that it took the penguin traveling that long to get back to its birthplace. So we want to make sure that we include some of the key details from the context, from the situation we're given, from the story, so that we are being specific with what our slope means. Now, let's say they wanted us to graph this. Well, we have the x-intercept already. So to graph it, we would need to find the y-intercept of the function. So if our equation is d equals 70 minus 2.4t, we learned that d is y and t is x. So to find the y-intercept, we're going to replace the x value, which is t, with the 0. So the distance the penguin traveled was 70 miles. Now here it said to find the y-intercept, so we're going to write that as 0, 70. So that's our x and y intercepts, also known as the zero of the function, the x-intercept specifically, and how we could explain what the slope means in the context of a situation. Next up, we are being asked to find the slope of a line that passes through each pair of points. So the slope we've learned is m equals y2 minus y1 over x2 minus x1. Now we're going to use that equation when given a pair of points. First thing you always do when you're finding the slope, even if you think you know better and you've got this, always label your points. Trust me, it is going to help you avoid mistakes. So I'm going to label it x1, y1, x2, y2. Now, does it matter if this ordered pair is the ones and this is the twos or vice versa? No, as long as it's consistent within the ordered pair. So now we're going to take those values and plug them into our equation. So our y's go on top because our slope is the change in the y value over the change in the x value, also known as the change in the dependent variable over the change in the independent variable. So we start with the y's. y2 minus y1. So that's going to be -5 minus -1. Then we do the x values. x2 minus x1. So that's -4 minus -4. Now simplify. This becomes addition. -5 plus 1 is -4. -4 plus 4 is 0. Now, if this 0 was on the top, our slope would just be 0. But because the 0 is on the bottom, that means our slope is undefined, or there is no slope. Let's try the same equation, but now if given a graph. So luckily our graph has included 2 points on our line. So we can use those points for our equation. y2 minus y1 over x2 minus x1. Now, I'm going to make sure to label my points. Again, remember, if I put 2, 5 first, it wouldn't mess up my equation. It wouldn't change my answer as long as I keep it consistent. So if this is y1, this needs to be x1. But I'm going to make this x1, this y1, x2, y2. Now that I've labeled it, I can easily, clearly place it into my equation. So y2 minus y1, that's going to be 5 minus 1. 2 minus 0 is my x2 minus x1. Now 5 minus 1 is 4. 2 minus 0 is 2. And if we can, we want to simplify our slope. So 4 divided by 2 is 2. So for this equation, our slope is 2. Now, remember, we learned that slope is rise over run. So I can check that that makes sense if I'm given a graph by counting out my slope. So if my slope is 2, that's 2 over 1. So I rise 2, and I run 1 for each point. That means if I start here with a slope of 2 over 1, I should be able to go up 2 and over 1 to get to my next point. So if I've calculated my slope correctly, I should land on an exact point on the line, which I do. Now, slope is consistent for the whole line, so I can continue counting up 2 over 1 to place the rest of the points on the line. And I could continue that indefinitely if I wanted to. So our slope was 2. Now, what happens if we're missing some information? Here, we're being asked to find the value of r so that the line passes through each pair of points and has the given slope. So they're giving us the slope and 1 complete point, but then we have an incomplete point. We need to figure out where on which x value we need to use in this point to give us a slope of 1 for the line. So I start the same way I would if I was finding the slope. I label my points, x1, y1, x2, y2, and m, my slope is already labeled. Then I plug it into my equation, m equals y2 minus y1 over x2 minus x1. So that becomes 1 equals negative 2 minus 8 over r minus 6, because my x2 is r, so I'm going to use that variable. Now I simplify what I can, which is this top piece, my numerator, and that is going to become 1 equals negative 10 over r minus 6. Now, to solve for r, I want to create a proportion. So I'm going to change my whole number 1 into a fraction that represents the same value by putting 1 underneath. If the slope is a fraction, you just write the fraction here and use that for your proportion as one of your ratios. If it's a whole number, we write 1 underneath to turn it into a ratio to then find our missing value using the proportion. Once we've turned this into a ratio, we cross multiply. So that would be 1 times r minus 6 equals 1 times negative 10. So r minus 6 equals negative 10. Well, from here, we just want to isolate the variable r. So we're going to add 6 to both sides. And we get r equals negative 4. So our missing point here, our missing value here is negative 4. If I were to plug that in and solve my slope, I would get a slope of 1. Let's try another one. So we have our equation, m equals y2 minus y1 over x2 minus x1. Now, as soon as I see the term slope in my question, that gives me like little alarm bells in my head telling me I'm going to be needing this equation. So that's why I wrote that down first and foremost. Just get that out of the way so I have it on my paper. Then I replace the values with the given information. So slope is 3/4. So 3/4 equals, this will be x1, y1, x2, y2. So r minus negative 3 over 7 minus negative 1. So I'm going to simplify that. 3/4 equals r plus 3 over 7 plus 1 is 8. Now I'm going to use the same method to solve my proportion for r. So I start with 3 times 8, 24, equals 4 times r plus 3. Now remember, when I multiply 4 times the r plus 3 term in this ratio, I have to make sure I'm multiplying 4 by both pieces of that term, of those, or both terms in that piece. So I put it in parentheses. Then I distribute. So 24 equals 4r plus 12. Then I subtract 12 from both sides. 4 minus 2 is 2. 2 minus 1 is 1. So 12 equals 4r. Now I divide by 4, and I get 3 equals r. So our missing value for r was 3. All right. Now the last one we're going to talk about today is a real-life situation in which we are using slope to analyze the change in something. In this particular situation, we're analyzing the change in Houston Astros ticket prices. So the question asks us to find the rate of change. Now remember, rate of change is our slope. So that tells me I'm probably going to be using y2 minus y1 over x2 minus x1. Now, I'm not 100% certain yet because I haven't finished reading my question, but I'm just going to write that down just to have it there because I saw rate of change. Now, it's asking us to find the rate of change of prices from 2006 to 2008 and then explain the meaning of the rate of change. So let's look at our graph that we've been given. So first we find the years that we're measuring, 2006 to 2008. So 2006 is here, and the value in 2006, the price of tickets for the Houston Astros was $26.66. Then in 2008, ticket prices rose to $28.73. So to find the slope, even when working in a real-life situation, we still want to use ordered pairs. So I am going to use my slope equation. Now, to put this information into this equation, I need to identify ordered pairs. So remember that this is your x-axis and this is your y-axis. So my first ordered pair, the x value is 6, and the y value is 26.66. Now for the next year, or the next year I'm measuring, it's 2008, and the y value for the ticket price is 28.73. Now I have two ordered pairs. So even though I'm working with decimals, I'm still going to plug it into or substitute it into my equation the same way I've been doing. So this is going to become my x1, y1, x2, y2. And I'm going to subtract 28.73 minus 26.66. So that's going to tell me the change in the ticket price during this time here. But if I want to know the rate of change, I need to calculate it per single year. So now I find the change in year, and that's x2 minus x1, which is 8 minus 6. So now I calculate my slope, 28.73 minus 26.66. We get $2.07. Not bad, and it only rose by about $2. And the change in the years was 8 minus 6, which is 2. Now, to finalize my slope, I'm going to simplify this and divide by 2. So my slope is 1.4, or $1.04 per every 1 year. So my slope is 1.04. Now they wanted us to explain the meaning of this. So that means if the slope is 1.04, my rate of change is $1.04. So the ticket prices increased by $2.07 from 2006 to 2008. Now remember, that's just the rate of change amongst or across those 2 years. But slope I want to simplify, so this means ticket prices increased by $1.04 per year during this time. So there's our slope, $1.04 per year. That's a total of $2.07 from 2006 to 2008. Now I want to point out, notice how this is not a straight line. That's because our slope changes from year to year, from period to period. So we started off with, a minor slope from 96 to 98. But then, I don't know, maybe they won a championship or something. I'm going to have to look this up because from 98 to 2000, Houston Astros ticket prices soared. Look how much they increased in that 2-year period. Then from 2000 to 2002, I guess they had a bad season because ticket prices kind of dropped a little bit even. So that's a nice little discount for those season ticket holders. But since then, it's risen pretty steadily, just not completely constant or consistently. That's why it's not a totally straight line. But that's how we would describe our slope in that context. So that is the end of our review. Now, as promised, if you have dedicated your time to watching this entire review, then you have earned yourself a little bonus. So for our bonus on this test, it's just going to be a little 1-point bonus. I want you to prove that you watched this video by writing my puppy's name at the bottom right corner. Those who haven't watched the video probably won't remember his name from our first day of school chat. So as a reminder for those of you watching, my cute little puppy, his name is Cooper. So you're going to write that on the bottom right corner of your test. So that would be down here if this was your test paper. All right? So that's your way of proving to me that you took the time and energy to watch this entire review video. And if so, not only will you do awesome on this test, but you'll be able to walk away from it feeling super confident. Great job, guys. I'm very proud of you. Keep up the studying and the hard work, and I will see you back in class next week.